Hello and welcome back to In-Comm Training Services YouTube channel. We are going to explore challenge 1 a little bit further, and we're going to look at electronic components. So if you're coming up with a solution for the use of modern technology, the groundwork really and the understanding is your knowledge and understanding of electronics and electronic components. So just a quick reminder that the challenge is to develop an idea for using modern technology to improve safety and environmental impact, supporting Gestamp in expanding its product range. Firstly, you need to understand electronic systems. When designing a system, whether it's electronic, pneumatic or mechanical, it's important to know what your product is capable of doing. What do you want the output to be? So an example of an output might be a light being switched on or a fan. So what do you want it to be capable of doing? Systems are often designed using a block diagram, or in the case of electronics, it is known as a circuit diagram. So a circuit diagram considers the input, the process and the output. How it works is the process, and the input is the part of the system that enables the process to start happening. Now, the understanding of electronics is something that you need to know for your GCSE science. So for more information, you can go onto the BBC Bite Size website, where there's lots of theory about electronics and electronic systems. So input, process and output. You need to think about selecting products to use in the production of an electronic system, and selecting them can be complex. These should be carefully chosen to ensure a product is functional. Think about what you want your modern technology to do. There are a range of different sensors and control devices and output devices that can be used together or separately, depending on what function the product needs to achieve. These components are split into 3 categories: inputs, process and outputs. So we're going to look at some examples of inputs and outputs during this short tutorial, and at a later stage we'll explore the process applications in a bit more detail. So let's look at some inputs. Very obvious inputs are switches. So if you're designing an electrical system, these are really bog standard switches that you'd buy, standard components. If you were designing a system to be embedded into a car, you would design your own casing for a switch maybe, or buy one that exists. But what you do need to consider is how that switch might function. So just running through a couple of these switches, a push to brake switch means that the circuit will work unless you push the switch. So the action of holding your finger down on a switch will stop the circuit from working. A push to make switch works in the opposite direction. So the circuit will only be activated if you hit and hold that switch down, but you've got to hold your finger on a push to make switch. So there's only certain types of applications where you'd want that type of switch. For instance, if you've got a hand torch, you might want to hold the switch to shine the light. But if you want the light to be permanently on, you need to look at a different type of switch. So a rocker switch, where it rocks back and forth and stays in that permanent location, so it can be permanently on or permanently off. A micro switch, which relies on a tiny lever that's made from a metal to make contact with the circuit. A slider switch and a toggle switch, both switches that can be permanently on or off. But again, the design of these switches very much depends on the electronic system that you're designing. Once you've got an idea of the types of switches, what you may want to do is explore electronic components even more, and you can use that website, which has hundreds and hundreds of components for you to look at to see which one's right for your circuit. So the other types of inputs that actually you may need to explore if you want to design a modern piece of technology are sensors. So sensors sense something. So it could be heat, light, a magnetic field. Sensors will start the circuit working once it senses enough of what it is it's there to sense. So for instance, an LDR, known as a light dependent resistor, senses light. So it will only work, you can actually program it to work either way really, but it will only work, for instance, if it's light or if it's dark. And when you design your system, you can control and monitor how much light is let in before it starts to work. So a light dependent resistor. The other type of sensor is a reed switch. Now a reed switch reads magnetic fields. So the circuit will only be activated when it comes into contact with a magnet. So we've got light, we've got magnetic field. Then we've got temperature. A thermistor senses temperature, so whether it's hot or cold. And then we've got a tilt switch, which monitors movement. And then we've got a distance sensor, which can sense the distance of an object. And its distance sensors are really quite good. They can actually sense fluids as well. So you could set it to sense the amount of fluid, the volume of fluid in a container. So again, these are sensors. So you've gone from switches, which are very simple components that you'd use in a circuit, onto sensors. So those are the range of inputs that we're going to expose you to, just to give you an idea of the types of inputs that you might integrate into a modern electronic system. So the process is the transfer of power from the input to the output. So the action that's taking place between the input and output to make the output work effectively. So the process might be the current flow. You might have an integrated circuit that monitors and controls the components while that currency is flowing through your circuit. Or you might make use of a microcontroller where you can get to actually program and control certain components. We will look at this in a bit more detail in the next tutorial, where we'll look at programming certain components. Outputs. Outputs are components or an action that will be activated after the process. So when you've switched on an input, or when your input has sensed what it needs to sense, that will carry the currency flow. The processor will process it and it will activate an output. So you've got to think about what it is you want to actually achieve from your piece of modern technology. At the end of it, do you want the user to be alerted using a buzzer, a small sound, a speaker, where you can obviously project various sounds and music, a lamp, or a light, a motor, so something moves, or a bright light emitting diode. So those are just some examples of the outputs that you could use as a starting point. You might want to explore other outputs. So again, to explore more components, it's really useful to go on Rapid Online and explore the electronic components on there. So to help you a little bit further, we spoke about using Rapid Electronics, but there's also lots of resources on the Institute of Engineering and Technology. On their education site, you can actually click and download a number of posters which will talk you through what you need to understand about electronics. We also mentioned BBC Bitesize, excellent resource for learning about electronics. And what's also useful on the Institute of Engineering and Technology is there is an excellent link to careers. So you can see where modern technology or your understanding of the automotive industry, what careers it could take you into. So I hope you enjoy this. Thank you for listening. We will be releasing other tutorials to support you through this challenge. But remember, who are you designing this piece of modern technology for? Always revisit the company. Thank you for listening. Goodbye.